Hello viewers, Wagadaruna taking you through today's tutorial for O-level math contest practice. And this video we are still continuing with the compilation of basics of algebra, and that will be part 2. So like I told you last time in the previous in part 1, these were trainings for senior 1 and senior 2 students who had passion to do national math contests when they reach senior 3 and senior 4. So by now they have those who are in senior 2 in 2023. That means that in 2026 they are joining A level, meaning that you have to step up the nature of training from the O level way to the A level way. That is why we thought it wise to release these compilations so that even those who are not there in those previous trainings and never did math contests in O level but wish to do it when in A level can follow through these videos and be on the same line with those who did math contests in O level. But for otherwise, those who are still in O level, this is a must watch video, and I encourage you to make good use of it. So before we go to the training, I'd like to display the books we have for the new curriculum. So for O level, we have 2 books for math and 2 books for physics. For the ones for math, there is Math Volume 1 of 4 of 2, having notes of senior 1 and senior 2. That means that the one which is pending is for volume 2 of 2, which will contain notes of senior 3 and senior 4, and we're still working on it. Item bank contains its complete senior 1 to senior 4. Physics for it is already complete senior 1 to senior 4 notes, and also the item bank is complete from senior 1 to senior 4. So in case of the copies, contact the author on this contact. For A level, these are the ones we have in store. There is Math Part 1, Math Part 2, and the item bank for pure math. So this item bank is basically for this. Then Physics Part 1, Physics Part 2, and the item bank for Physics 2. So this item bank is basically for Physics 2. And the reason is because those who are now joining Senior 6, if you are following the curriculum, should be doing topics of Physics 2. Otherwise, Physics 1 is what they begin with in Senior 5, Term 1 and Term 2, meaning that is why we chose to begin with Physics 2, then we shall do Physics 1 so that those who are joining Senior 5 can find it already in stock by then. So with those brief remarks, I can leave you to enjoy the recordings. Hello viewers, Wagadaruna taking you through this tutorial for O-level math contest practice. And this video, I'm going to go through the basics of algebra and especially indices. So an index, indices is the plural and index is the singular. So an index is the number of times the base is multiplied by itself. For example, this one means multiplying a by itself n times. Therefore, this n becomes the index, and this a becomes the base. So that means that if I write 2 to the power 5, 5 becomes the index and 2 becomes the base. So it means that I have to multiply the base 5 times. Now most students confuse it with thinking that this is 2 times 5, which is not correct. So this one means it is not equal. So what does 2 to the power 5 mean? It means you multiply 2 by itself 5 times. 1, 2, 3, 4, 5, like that. So in the next slide, we shall see how to use a calculator to get the value of 2 to the power 5 without first expanding it. But this is how they expand such. So we need some rules when dealing with the questions involving indices, and we shall look at them step by step. So the first one is called the rule of powers. This one says that when raising a power to a power, keep the base and multiply the indices. Remember, we said indices means powers. So it means that when I'm multiplying a to the power m raised to the power, when I'm given a to the power m, everything raised to the power n, it means that you keep the base, which is here, and multiply the powers, m times n. Then also, this is also very important, because multiplication, if I write 2 times 3, it is the same as 3 times 2. So it means that if I write this, I first begin with the power of m followed by power of n, it is the same as beginning with the power of n followed by the power of m, because at the end of it all, we have to multiply. So this rule is very vital, and we shall see how vital it is. So letter A denotes any number. It can be 2 to power this, it can be 3, it can be 4, it can be anything. It can even be a fraction. So how do we use a calculator to deal with indices? Suppose I want to obtain the value of this using a calculator. What do I do? So there are two forms of calculators, but what I believe is that most of you have this type of calculator based on your level. So that's what we are going to look at mainly. So to press 5 to power 2, everything raised to the power of 3, you are going to press this open bracket, then press this 5, open bracket is here, then press the 5, then next we need a power. Now to get a power on this calculator, we use this symbol. So I'm going to press that button. Then from there, we need power 2, so you press 2, then you close the bracket, then we need another power of 3, so we're going to press again this power symbol, then followed by a 3, and then we press an equal sign to get the answer. So when we press an equal sign, we shall come up with this. So this is what you will see on this screen, but if you have such a calculator, then this is what you will see. So that is how they use indices. That's how they press indices on calculators. We use a symbol. We use this symbol, and it is found here. What if? Remember, we want to prove the rule that if I interchange the powers, it will still give the same answer. Now here I first began with 2, the power of 2 followed by power of 3. What if I begin with the power of 3 followed by power of 2? Will I still get the same answer? Let us try. We are going to press still open bracket, then 5, then a power, and then 3, close bracket, a power, and then 2. Then press an equal sign. So when you do that, you'll come up with this. And I think realize the answer is still the same, because previously we saw it was 15,625, and even now we are getting 15,065. But they also told us that if you get the power, if you get 5 to the power of the product of these two, it is equal. So let us see, what if I want to press 5 to the power 2 times 3? Will I still get the same answer as before? Let us try. We will press 5, then the power, then there's a bracket, then 2 times 3. So press 2 times 3, close bracket. Think everything is done. You can press equal to, you'll come up with this answer on your screen. So I think that it is still 15,065, even in this case. So all these ones are equal. Therefore, our rule for powers is correct. So basically, that's how we use calculators to deal with indices. So we shall come and note that all these ones give the same answer, implying that the rule is correct. Then with that, we can go through this question. So question 1 says, simplify the following using the rules of indices. 2 to the power 3 to the power 2. It means you keep the base constant and multiply the powers. Apply these powers here to give you 2 to the power 6. What about x to the power 4 to the power 5? Keep the base constant and multiply these powers to give you 20. So that is about the rule for powers. What about the rule for multiplication? So it states that to multiply numbers with the same base, I believe by now you know what a base is. Keep the base and add the indices. Indices, I believe you know what it means. It means the power. So if I'm multiplying a to power m times a to power n, first of all, you should realize that the base is the same. Now they told us you should keep the base and then add the indices. That's why you see here m plus n. That was if the base is the one which is the same. What if instead of the base being the same, it is the powers? What would you do? So if the power is the same for the different bases, then the product of the powers is the power of the product. So you realize this is A, this is B as the base, but the powers are the same. So what you do, you keep the power constant and multiply the two bases. This one is also very vital. So all the rules we are going to look at are very vital. So before we forget the rule, let's first do these two questions. Question 1 says, simplify the following using the rule of indices. Part A, this times that. So the base is the same, but the powers are different, meaning we are going to add the powers. Keep the base, add the powers to get the answer. Part B still, the base is the same, the powers are different. Keep the base, add the powers to get the answer. But for question 2, you realize that these bases are different. It is the powers which are the same. So to remove the power, that means this one multiplies each. 3 to the power 2 times 8 to the power 2 to give you 9a squared. Then also same applies to part B, the power multiplies everything. So 3 to the power 4, a cubed to the power 4, b to the power 4. Now here we still again bring in the rule for powers. We multiply the two powers to come up with 8 to the power 12. This one is 81 if you use the calculator, and this remains b to the power 4. And that's what they wanted. So that is the rule for multiplication. What about the rule for division? For multiplication, we added. For division, we subtract. So it says that to divide numbers with the same base. Keep the base and subtract the indices. So I have this, realize that this base is the same, but these are different. So keep the base and subtract the indices. But it should be noted that a can never be 0 because a number divided by 0 is infinity. That was if the base is the one which is the same. What if it was the powers which were the same? Still do the same, keep the power constant, and then you divide the two bases. So it should be noted that the denominator can never be 0. So before we forget this rule, let's also do some few questions so that it can enter our heads. So simplify the following using the rules of indices. For part A, same base. So you subtract the powers. Keep the base and subtract the powers to get the answer. Same applies to part B. You are going to keep the base, subtract the powers to get the answer. For question 2, they want us to open brackets, so the power is on each term. So that gives you 2 to power 3, x to power 3, y to power 3, to give you that as the answer. Then still for this one, x squared to power 3, 2 to power 3, y to power 3. This one, the powers are multiplied to give you 6. And that's what they wanted. Now there's what we call zero index law. What if the power is 0? What do you get? So any number or expression with a power of 0 must be equal to 1, always. So whatever you see, if the power is 0, just know that the answer should be 1 for all a not equal to 0. So this a cannot be 0, because 0 to power 0 is not for our level. But someday at campus, you realize that it has an answer. The negative index law. If a is a non-zero number and n is an integer, then a to the power negative n is the same as the reciprocal. It's the same as 1 over a to the power n. So when you get the reciprocal, the sign changes. If it was minus, it becomes positive. If it was positive, it becomes minus. So that means that this and this are reciprocals of one another. So you should remember that a to the power negative 1 is the same as 1 over a. Similarly, if it is a fraction, still the rule works. It has to be reciprocal, because we said when the power is positive and when the power is negative, they are reciprocals. So here when the power is positive and this one the power is negative, so when the power is negative and this one the power is positive, they are reciprocals. So here it was a over b and here it will be b over a, which is a reciprocal. So before we forget that, let's do some questions. Question 1 says, write the following without brackets or negative indices. So to make this power positive, you get the reciprocal, which is t over 1, and this becomes positive. T over 1 is t raised to the power 2 becomes t squared. Then this one, the whole of this is the reciprocal, so it will be 1 over xy. In the end, we shall come up with 5 over xy. Then for part C, here the power was on both xy, but here the power is on only y. So it is y where we shall get the reciprocal, and we end up with 5x over y. Actually, these two are confusing to many students, but I encourage you to master them. Be keen when you have such. Then part D, still we are going to open brackets. So this one is this, and this is this, but realize that this is a negative power, so we have to get its reciprocal to become y squared over 1, which remains y squared. Then this one, same base, you add the powers, and then you get the final answer. So that was that. Then you shall go to fractional indices. So what if the power is a fraction? What you should always remember is that if the power is 1 over a certain number, it means the nth root. If it is 1 over n, it means the nth root of the base. So if I write 2, if it is 2 square root of 2, it means in indices it will be 2 to the power a half. So with that, we shall go through these questions. Without using tables or calculator, evaluate the following. So let's start with part A. Part A, this is what we are given. First thing to do is to prime factorize. 16 becomes 2 to the power 4. The power remains the same. 64 becomes 2 to the power 6. This remains the same. 8 becomes 2 to the power 3. 125 becomes 5 to the power 3. This remains the same. Then from there, we remember these are both powers, so we can multiply the two. So 4 times a half, then 6 times negative a third, then this times this, and also this times this. Then you can simplify. This gives you power of 2, this one gives a power of negative 2, this one a power of 2, and this is a power of 2. Then 2 to the power 2 is known 4. This is the reciprocal, which is 1 over 4. This one is 4, this is 25. Because we don't use a calculator, we have to get the LCM. And this would be the answer they wanted. Then for part B, that's what was given. The first thing to do is to prime factorize. 12 becomes 3 times 2 to the power 2. 16 becomes 2 to the power 4. 27 becomes 3 cubed. 18 becomes 2 times 3 to the power 2. Then you should remember that this one we can, to open brackets, this multiplies throughout. So this times this, it gives you that. This times this, it gives you this. And this times this, we get that. That is for the numerator. For the denominator, this and this gives you that. Then here, this half with this gives you 2 to the power half. And this times this gives a power of 1. Then from there, we shall collect like terms. Numerator has 2 bases which are the same, so you add the powers. Denominator has 2 bases which are the same, you add the powers. Then you simplify, you'll come up with this 3 over 2 here, 3 over 2 here. So 1 over 2 and 1 over 2. Then you same base, this is division. So you have to subtract the powers. Also, this is division. You subtract the powers. When you subtract, you come up with this, a power of 0 and a power of 3 here. We already saw that any number at power 0 is 1. And 2 to the power 3 is known as 8. So the answer is 8. And that's what they wanted. Then shall go to what we call equality of index expressions. This one means if 2 index expressions are equal and their bases are the same, it implies that the indices of these expressions are equal. So if I want to realize something here. This base is the same, but these powers are different. One is A, one is B. But because these bases are the same, CC, it implies that even A is equal to B. Now, this one is very vital, and we are going to look at a number of examples. I think you can see here, there are 4, so that we can master it. So let's start with part A. Part A, the first thing to do is to prime factorize. 16 gives 2 to the power 4. Then you realize that the base is the same, meaning the powers should also be the same. So 2x must be equal to 4. Then you can get the value of x. And that's what they wanted. Then for this part B still you are going to prime factorize. 125 becomes 5 to the power 3. 25 becomes 5 to the power 2. Then here, same base, you add the powers. And here, powers, you multiply the 2 to come up with 2k. Now here, the base, this base is the same, so it means this 10 is equal to 2k. Meaning that k is equal to 5, and that's what they wanted. So that's how they use the equality of index expressions. But let's proceed to these and also attempt these other remaining parts. For part C, that's what we are given. So 1 over 8 is the same as 8 to the power negative 1. Then 8 prime factorize it, become 2 to the power 3. Therefore, multiply this by this gives you negative 3. Meaning this is the same and this should also be the same. So 2y is equal to negative 3 and y is equal to negative of 3 over 2. Part D, this is what we are given. This dot B means a product. So let's change it and put what we know, multiplication. Then you prime factorize this to come up with this. Then now here, what you do, you compare. This 2 is this 2, meaning this x should be 4. This 3 is this 3, meaning this y should be 3. So that those will be the values of x and y. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on SATs. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Hello viewers, we are Gadarena taking you through the story of O-level math contest practice. And this video we're going to go through the basics of algebra, particularly SATs. So there are two words, SATs and radicals are numbers that are written using the radical sign, or what we call the square root sign. So this is what we call the radical sign, or commonly known as the square root sign. So both sides and radicals occur frequently in mathematics, often as solutions to equations involving squared terms. I think you remember seeing it under Pythagoras theory, which we covered in the previous holiday. So let's begin by two words, rational and irrational radicals. These are the ones which will help us to understand what a SAT is. So some radicals are rational, but most of them are irrational. So rational examples can include square root of 1 is the same as square root of 1 squared, which is 1. Square root of 4 is the same as square root of 2 squared, which is 2. Square root of a quarter is the same as square root of a half squared, which is a half. Those are rational. What about irrational? Irrational radicals include square root of 2. If you press the calculator, you'll come up with this and more decimals. I've just rounded them off. Square root of 3, which is this and more decimals, I've just rounded off. So strictly speaking, a SAT is an irrational radical. So these ones are known as SATs. So I believe by now we know what a SAT is. Now we shall go to what we need to know in multiplication and division of SATs. So I want you to realize that if I write square root of 4 times 9 is equal to square root of 36, which is 6. And also, if I write square root of 4 times square root of 9 is the same as 2 times 3, so 2 is this, and 3 is this, which gives you 6. Do you know what that means? It means that root of this times root of this is equal to root of the product of both. Same applies to division. If this 36 over 4 gives you 9, which in the end gives you 3, we will get square root. Also, square root of 36 is 6, square root of 4 is 2, which gives you 3. So to imply that this is also correct. With that, we shall come up with a rule involving multiplication and division of SATs. That if you multiply these two sides, the same as square root of both of them, what is under the root for both. Same applies to division. Individual square root is the same as square root of both quotient. Then what about addition and subtraction? For here, like SATs, we use what we call like SATs. So like SATs can be added or subtracted in the same way as like terms in algebra. For example, in algebra, we could say x plus 2x. You can add it to get 3x. So then here, like SADs can be added or subtracted in the same way. For example, what do they mean by like SADs? Like SADs, remember this is a SAD, this is a SAD. So they are all the same. That's why we call them like SADs. They can be dealt with the same way we deal with 3x plus 7 plus 4x. Because in algebra, in like terms, when we add these two, we come up with 7x. Meaning that here we shall also come up with 7 root 2. So we can interpret this as 3 lots of root 2 plus 4 lots of root 2 gives you 7 lots of root 2. Meaning that this gives you this when you add, just as this gives this when you add. So that's basically how we can add or subtract SADs. Therefore, the following rule is true. This one means a plus b of root c, a minus b of root c. However, it is not the same. You should be keen not to do this and also not to do that, because it is not correct. Then simplest SAD form. A SAD is in its simplest form. So here there was something missing. A SAD is in its simplest form when the number under the radical sign is the smallest integer possible. For example, if a SAD can be expressed in this form, then it means that this one has to be pulled out to become a root b. That's how you can express it. That's how you can simplify a SAD. And with this knowledge, you shall go through these questions. Then realize that all these ones, they are different, but they are not yet simplified. So let's see what happens if we simplify them. Let's start with part A. Part A, we are given this. This one is the same as 81 times 3, and this is 36 times 3, and this is 25 times 3. We all know that 81 is 9 squared, 36 is 6 squared, 25 is 5 squared. Meaning this 81, square root of 81 alone is 9, then you remain with root 3. Square root of 36 is 6, so which is here, then you remain with root 3. Square root of 25 is 5, and you remain with root 3. So I think we realize that these are like SADs. So just add the same way we could add, for example, 9x minus 6x, then plus 5x. Here we would have got 9 minus 6 to give you 3, 3 plus 5 to give you 8x. So that's why you see here 8 root 3. Then this one also, we have to change. This becomes 9 times 5, and this 20 is 4 times 5, 80 is 16 times 5. So 9, square root of 9 is 3, and you remain with root 5. Here there is a 3, then square root of 4 is 2, you remain with root 5. Square root of 16 is 4, you remain with root 5. So 3 times 2 is 6. Then here, like I said, we take it as like terms in algebra. So 3 lots of root 5 plus 6 lots of root 5 minus 4 lots of root 5. It gives you, let me say, 3 plus 6 is 9. 9 minus 4 is 5. So you get 5 lots of root 5. Then part C, still do the same. This is the same as 144 times 2. This one is already simplified. Then this is 36 times 2. So square root of 144 is 12. You remain in the root 2. This one is already simplified. Then square root of 36 is 6. You remain with the root 2. Then you say 12 lots of root 2 plus 7 lots of root 2 minus 6 lots of root 2. What do you get? So 12 plus 7 is 19. 19 minus 6 is 13. That's what remains with 13 lots of root 2. Then question part D. So this is the same as this one. So I believe by now you know how this comes about, because 50 is the same as 25 times 2, but 25 square root is 5. Then also this is already simplified. Then this one is, here I believe you know how it comes about, because 800 is the same as 400 times 2, where square root of 400 is 20. Then this one also I believe by now you know how it comes about. Then you'll add. First of all, this gives you 10. So 10 minus 3 is 7. 7 plus 20 is 27. 27 minus 6 is 21. So remaining with 21 lots of root 2. That was simplifying surds in the simplest form. So what about expanding brackets involving surds? So the same rules we used in expanding algebraic expressions are the same rules we shall use. I think by now these rules you are familiar with them. That's what we shall use. So we shall use them to go through all these solutions, and I believe by the end of it you'll have known how to expand surds. So let's start with part A. We have to recall this distributive law, whereby this times this and this times this, whereby what is outside the bracket multiplies everything inside the bracket. So root 2 times root 2 gives you root 2 squared. Then root 2 times root 3 gives you root 2 times root 3. Then you remember that this is the same as 2, and this is the same as root of 2 times 3, which is root 6. And that's what they wanted. Then part B, still we use this distributive law. This times this, then this times this, to use that. This is okay, but this one, root 3 squared is 3. But there's a 2 outside, that's why he said 2 times 3. So 2 times 3 is 6. So in the end, you come up with this as the answer. Then part C still is negative, so negative root 2 times this. Then, so you should be keen here. If you put this bracket negative inside, then it is not okay, because it is negative root 2 times positive root 2. So negative times a positive, you get a negative. Then negative root 2 times this gives that. So this is 2 and this is that. Then still distributive law, this times this. So this times this gives that. This times this gives this. So here, this is okay. But this one, this is root 3 squared is 3 times 2 to give you this part, which is where we end up with this. Then part E, we need to recall this, how to expand this, that square this, then type plus the product of, twice the product of the inner terms, then plus the square of the next term. So that's the rule we use here. So square this, twice this product, then square this. That's how they expand. Then you simplify. This squared is 3. Then this one, you realize that 2 times 2 is 4 times root 3 to give you 4 root 3. 2 squared is 4. Then you collect like terms. 3 plus 4 is 7 plus that. That's the answer. Some students are funny. When they see 7 plus 4 root 3, they may think they can add these 2 to get 11 root 3. That is not okay. Then you also recall that, then you use it. Square this minus the product of both entries, twice the product of both entries, then plus square that. So this squared is 3, then this one, this times this is root of 21, so there will be 2 root 21. Then this one becomes 7. Then you collect like terms, this plus this is 10, and you put that. Then G, still recall this, that this is difference of 2 squares. So realize that this is difference of 2 squares because this term is the same as this and this is the same as this, but the difference is that there is a difference in a change of sign. So we shall get difference of 2 squares, where this is squared minus this squared. So this squared is 9 and this squared is 2. You come up with 7. Same applies to this one, because still this term is same as this term and this same as this, but it's only the sign which has changed. So we still use difference of two squares, where this squared here and this square minus this squared. So this squared becomes, remember this power multiplies each entry inside. So 2 to power 2 is 4 and root 3 squared is 3. That is why we come up with 4 times 3. Then this is 25. So 12 minus 25 gives you negative 13. So I believe by now you have learned how to expand surds. Now we shall go to the next part, which is division of surd, division by surds. When an expression involves division by a surd, we can write the expression with an integer denominator, which does not contain surds. So in mathematics, if you look at this, if you leave your a surd in the denominator, then you have not yet completed the solution. So it is not the final answer. So always in mathematics, ensure that the denominator is an integer. Okay, so if the denominator contains a simple surd such as this, then we use the rule of this times this equal to this, which means that we multiply both the numerator and denominator by the root which is in the denominator. If you look at this, it was this. So to remove the surd, we multiply up and down by root a, up and down by root a to come up with this, because root a times root a is a. So you'll have removed the surd in the denominator and you remain with an integer denominator. So you're going to use that rule to simplify these ones to get an integer denominator for each. So for the first one, multiply up and down by root 3. So this becomes 10 root 3, this becomes 3. And there you'll have got an integer denominator. Then also for this, multiply up and down by root 5, you come up with 7 root 5 over 5. You have got an integer denominator. Then for this one, still multiply up and down by root 2. First of all, this simplifies with this to give you 5. Then multiply up and down by root 2 to come up with this, which is an integer denominator. Then also this multiplies, first of all simplify, because 8 can be reduced in its simplest surd, which is 2 root 2. And we have 2 root 2 root 2. This cancels, remain with only 1. That is if it is a simple surd in the denominator. But what if the denominator is in the form a plus root b? We can remove the surd from the denominator by multiplying both the numerator and denominator by its radical conjugate. Now, radical conjugate means the sign changes. The sign on the surd changes. Here the surd was positive plus root b, here to be minus root b. And this process is called rationalization of the denominator. So we shall go through these ones, and by the end of it, you will have mastered the concept of rationalizing. So first of all, this one, we are going to first multiply up and down by the conjugate, which is 5 minus root 2, up and down. Okay. Then from here, 1 times this remain the same. Then here realize that it is the difference of two squares, which becomes 5 squared minus 2 root 3 squared. Okay. Then this is 25 and this is 12. How does 12 come about? 2 squared is 4. Then root 3 squared is 3. So 4 times 3 gives you 12. Then again, 25 minus 12 gives you 13. So I've succeeded to get an integer denominator. So we stop there. Then for part B, still the same. Multiply up and down by the radical conjugate. Then up, you still use rules of algebra. So actually this is this. You realize this? Same expression. So it's the same as this squared. And if it is squared, perfect squared, you know what to do. Square the first term, then plus twice the product of both entries. So twice the product means 2 times 3 times root 2, which gives you 6 root 2. Then plus the square of this, which is 2. That is for the numerator. What about for the denominator? For the denominator, it is the difference of two squares. So this squared minus this squared. You rather that you come up with an integer denominator, and that's what they wanted. Then part C, still do the same, apply up and down by the radical conjugate. Then you expand. Here, still the same thing, because this and this, it is a perfect square. So this squared is this minus twice the product of these entries, which is here, then plus the square of this, which is here. For that's numerator, denominator, difference of two squares, so this squared minus this squared. The next is to simplify. You see, this became 45. How did it happen? Because 3 squared is 9, then square root of 5 squared becomes 5, which is 45. Then this became 12 root 3, 15. How? Because we have this 2, okay, times this 3, okay, times this 2, which gives you 12. But for the sides, we have root 5 times root 3, which is root 15. Then this one, we already saw what it comes about, 4 times 3 to give you 12. So difference of two squares, this is 45 and this is 12. You will come up with an integer denominator. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on logarithms. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded. Hello viewers, Swagadaruna taking you through this tutorial for O-level math contest practice. And this video I'm going to go through the topic of logarithms, which is under the basics of algebra. So this video is suitable for students in both Senior 1, Senior 2 and Senior 3 with passion to one day participate in the national math contest. So let's start with logarithms of base in base A. So logarithms were created to be the inverse of exponential functions. We have been seeing in the topic of indices a to power n, for example, equal to x, like that. So logarithms are the inverse of these exponential functions. For example, if I write 10 to power a equal to x, it means that this a is the logarithm in base 10 of this. But we shall look at that. Shouldn't confuse you. For now, just know that inverse of exponential functions, and along the way on this video you will be able to easily grasp what a logarithm is. So if y is equal to a to power x, we say that x is the logarithm of y in base a. Hope you get the logic. X is the logarithm of y in base a. And write it as x will be equal to logarithm of y in base a. So for example, this we know that 8 is equal to 2 cubed. It means that 3 is equal to logarithm of 8 in base 2. So there's two statements, this and this are equivalent to each other. Meaning that if I'm given this, I can write this, or if I'm given this, I can write this. They're still the same. So other examples, if I have this, I can write it as that, if I want to introduce in the logarithm. Then if I have this and I want to eliminate the logarithm, I can write this. Remember, for now we are still on introduction, so if it confuses you, don't worry. We are going to grasp it when we come to worked examples. So 9 squared, so 3 squared equal to 9, it means that 2 is equal to the logarithm of 9 in base 3, which is here. This means that a half is equal to logarithm of 2 in base 4. So in general, this and this are equivalent statements. Okay, so now if the introduction has this confused you, don't worry. Just concentrate on this question. You realize you'll be able to master what I've been trying to say. So the question says, find the value of the following. Logarithm of 28 base 2. So we shall let it to be x. Then remember that we said this to power this is equal to this, which is here 2 to power x is equal to 128. Then I can prime factorize this with a base of 2 to give me 2 to power 7. So same base I'll be equal, it means that x is equal to 7. But remember that x is equal to the whole of this, meaning this will be equal to 7, and that's what they wanted. So that is why we said logarithm is the inverse of exponential functions. Somewhere there is a relationship with indices and logarithms. Then for this one, shall so let, then we say this to power this is equal to this. Then from there we can prime factorize 81 and get x as 4, meaning that log of 81 base 3 is 4. Part C still will let, then say this to power this is equal to this. So that is the only logic which I wanted you to grasp in the introduction part. Then prime factorize and get the value of x as 3, meaning that log of 125 of base 5 is 3. Then next is this. So 10 to power x is equal to this. Then this one first is to make it as 1 over 1000. Then you use express in terms of indices. Then get the reciprocal, meaning that x is equal to -3. Therefore, the answer they want is -3. So that is what I wanted you to grasp in the introduction. Now we shall go to the main part of logarithms, and that is rules for logarithms. So logarithmic expressions can be simplified using the following rules. There are like 5. So one is that logarithm of x base a plus logarithm of y base a is equal to logarithm of x times y base a. What do you realize here? One is that both logarithms have the same base, and two is that there was an addition here which is now replaced by a multiplication, but the base has remained the same. So why do we say it is the inverse of exponential? For exponential, if the base was the same, there was supposed to be a product, and that product would result to same base and you add the powers. Now, because logarithm is the inverse of exponentials, now here we don't need a product, we need an addition. And when you have an addition here, we get a product. For indices, it was a product giving rise to an addition. But for logarithms, it is addition giving rise to a product. So that is 1. That's why we say inverse. So for rule 2, it is the minus gives rise to a division. But you should take note, the base must be the same. So that you keep the base constant and you divide these two terms. The first one is the numerator, then the one after the minus is the denominator. Then the next rule, all these rules are very vital and you shall be playing about with them to answer the questions. The next rule is that if log of x to power n to base a, do you see this power? This x has a power, so it is the same as bringing the power down to become n times log of x base a. Then next, this one is a little simpler. A to power 0 is equal to 1, meaning that logarithm of 1 base a is equal to 0. Then a to power 1 is a, meaning that logarithm of a base a is equal to 1. This one is very vital. Do you see this? They are the same, meaning that the answer should be 1. So those are the 5 rules of logarithms, and they are very, very vital. Sometimes they will not put this. If they just say log and they put y, it means the base is 10. So that's what this note is talking about. When the base is not given, the base is 10. For example, log 8 means log base 10, log of a base 10. So we are going to repeat the questions which we did earlier on, but this time on we are going to use the rules of logarithms. Remember, the first question was introducing you to logarithms, but now we need to master the 5 rules of logarithms to answer questions in logarithms. So we are going to repeat the question this time around, answering it using the rules of logarithms. So it was this. So the rules says first is prime factorize this to get this. Then I think to remember rule number 3, it said when this has a power, you can bring the power down. That is why we have this 7 and 2 base 2. Okay, then you remember rule number 5. Rule number 5 says when these are the same, then the whole of the logarithm is equal to 1. So 7 times 1 gives you 7. Let's go to part B. Part B still, you're going to do the same. Prime factorize this to get that. Then bring this power down to give you this. Then look at this. They are the same. So the whole of this becomes 1 to give you 4. I think if you compare them with what we got earlier on, the answers are the same. Then this one still prime factorize. Then bring the power down. Then this one means the whole of this is 1. Then also this, we have to prime factorize this, but before that to get a fraction, there are 2 ways. One is to first get a fraction, then this one, I'll use rule number 2 to get this minus. Then from there I can, for this to this, I used rule number 4. Then from here to here, I have to prime factorize. Then I can be able to use rule number 3 to bring this power down to give you this. Then I'll use rule number 5 to make the whole of this 1. In the end, I'll come up with -3. So the 5 rules of logarithms are very, very vital. But remember, in this video, I'm only giving you the basics. Then it's the basics for you to be able to critically think about the rules and answer the questions in the math contest. So question 2 says evaluate this. So still you're going to use the rules. So I want you to be keen. First is to prime factorize. So this becomes this becomes this becomes this, and this becomes this. Then next we are going to use rule number 3 to bring the power down. So bring this power down to come up with this. Bring this power down to come up with this. Bring this power down to come up with this. Bring this power down to come up with this. Then next is rule number 5, because these are the same, meaning the whole of this is 1. These are the same, the whole of this is 1. These are the same, these are the same. So we shall remain with 3 here, 6 here, 5 here, and positive 1 here. Then from here I can use a calculator to come up with 1.5, and that's what they wanted. Then question 3, solve for A in this. First is to eliminate the logarithm. To eliminate, we said this to power this is equal to this. So let's use that idea. Then we shall come up with a quadratic equation, then we solve it. Sum is 1, product is -6, factors will be 3 and -2. Like I said, when here the quotient is 1, it is the same as a plus this to give you that. Then you can get the roots, the values of a. Question 4, solve the equation this. Okay, so first you realize that the base is the same. Do you see that? This and this is the same. And here there's addition, meaning we can keep the base and get the product of these two. To give you this step. Then we expand this, or we can eliminate the logarithms. To eliminate the logarithms, actually this is the same step, you don't need to write it. So to eliminate, I'll say this 10 to power this is equal to this product, which is here. That's how they eliminate logarithms. Then I can expand and collect like terms to get a quadratic. Solve the quadratic by getting sum as 1, product as -12, factors will be this. Meaning I can get these factors, then the roots will be that. So since logarithm of a number can never be negative, logarithm of a negative number doesn't exist, it means this x cannot be this, meaning that x is equal to 3. So this note is also vital. Logarithm of a negative number gives a math error on the calculator, as we shall see with time. Okay, so now we have looked at the rules of logarithms. Now we need to understand something also, how to convert from one base to another. So if logarithm of x base a is to be converted into another base, say b, it means that we shall use this. How does it come about? To change this to base b, it means log of this base b will be the numerator and log of this base b will be the denominator. As simple as that. Numerator is log of x base b, denominator is log of a base b, and that will be the answer. That's how they convert. So let's start with, you apply that on this question. It says show that this is equal to 1 and hence evaluate this. If you look at this, they have changed base. Here the base was a, here the base is x. So that is what is given. Then what I'm going to do, I'm going to change this to base A. Change this to base A. It means our numerator will be logarithm of A base A, and denominator will be logarithm of X base A. Then if you remember rule number 5, this gives 1. And this can cancel. So this will remain with that, and this gives 1, which is the proof they wanted. So in summary, if I'm to interchange these ones, then it becomes a reciprocal. For example, here it was logarithm of X base A. What if I want to change it to say that this X becomes the base and this becomes the number? It means I have to get the reciprocal. So now that I've got the proof, I can get the hence part. This one, prime factorize, this becomes this. Does it make sense? Because let's say why. 8 is the same as 2 to power 3, but I've brought the power down to give you this. Then 9 is the same as 3 to power 2, but I brought this power down to give you this. Hope now it makes sense. Then you collect like times 3 times 2 is 6. Then you write this and you write this. Then from this proof, you realize that here, these are the same, only that they have changed positions. And from this proof, they said when they just change, product is 1. So that's why you get the whole of this becomes 1. And in the end, you get 6. Then question 2 says, find this without using tables or calculator. So first I realized that this is the same as 3 to power 3, and this one is the same as 3 to power half. Same base, you are going to add the powers to get 3 to power 7 over 2. Meaning that log of this base 9 is the same as this. I've replaced the whole of this with 3 to power 7 over 2. Then from rule number 3, this power can go down to come up with this. Okay. Then from the rule of from the change of base, I can interchange these two by getting the reciprocal. Then I know that 9 is the same as 3 to power 2. Then bring these 2 down to come up with this. Then rule number 5, this means the whole of this is 1. So I remain with only a half. Then a half times this will come up with 7 over 4. Question 3, find x if this is equal to this. Now here, in the base are different. So how do you deal with that? The first thing to do is to change everything into one base. So let me change everything to base 2. And I'm doing that because when I prime factorize this, the base will be 2. So change this to base 2. It becomes logarithm of 8 base 2 as the numerator and logarithm of x base 2 as the denominator. For this one becomes logarithm of 16 base 2 as the numerator and logarithm of x squared base 2 as the denominator. So this 8 is 2 to power 3 and this 16 is 2 to power 4. Then next I'll use rule 3 to bring the power down. Also here bring the power down. Bring the power down here also. So multiply throughout by log x of x base 2 will come up with this. Then here, this and this are the same. It is 3 lots of log base 2 of 2 minus 2 lots of log base 2 of 2, which gives me log base 2 of 2. equal to this. Now here, there are two ways of going about this question. One is to cancel this log base 2 to remain with 2 equal to x. It is okay. Another one can say that the whole of this becomes 1. So 1 will be equal to log base 2 of x. Then how do you deal with it? You will say 2 to power 1 is equal to x. Either way, you'll come up with x as 2. Then question 4, solve this. Now still here the bases are different, so that means that along the way we have to convert. So this one, 8 becomes 2 to power 3, which is this. Then here realize that this and this, they are the same, only that they have been interchanged. So that means that if I want to make this one the base, I'll have to get the reciprocal. Think to remember that under converting a base. Then I will let y be equal to log of x base 2. Let me substitute. Now I think now it is simpler. I can multiply followed by y and rearrange to get a quadratic and then solve it. I believe by now you know how to get the factors. So the values of y will be this and that. But we know that log y is equal to this. So for each value of y, we shall be able to get the value of x. When y is 3, it means that this is equal to 3. To remove the logarithm, I will say 2 to the power 3 is equal to x. Therefore, x will be 8. Then when y is negative 2, it means that is equal to when y is negative 1, this is equal to negative 1. So 2 to the power negative 1 will be equal to x. Therefore, x is equal to a half. So now we shall go to indices reduced to quadratic equations. Now, previously, we could solve questions like, for example, 2 to power x equal to, let me say, equal to 8. Because 8 could be prime factorized with a base of 2. But some questions, it is not easy to prime factorize. For example, if you look at a question like this, when they give it to you and they tell you to find x, it becomes very hard for you to find it. So what do you do in such a case? So in this case, we have to introduce logarithms. Use the knowledge of logarithms to come up with the answer. For example, if I'm given this, the first thing to do is to put logarithms on both sides. Then I remember the rule, because remember they said if there is a log and there is no power, there's no base here, the base is always 10. So I remember the rule that this can come down to give you this. Then I can easily make x the subject by dividing both sides by log 2. So now we can use a calculator to get the value of x. So how do you press? Calculators, there is this form and this form. But what I believe is that most of you have such types of calculators. Now these calculators, there is a button of logarithms here. You see there is log, if you're using this, there is log also there. So to press, if I want to press to get the value of this, I'm going to press log, that button of log, then 7, then division, divide the division sign, then I press the button of log, then a button of 2, and then press equal to. When I press that, I'll come up with that value. Log 7 divided by log 2, it gives you 2.80735492. Then you can just round off to get the value of x. So In such cases, the values of x are only approximate values because there are many decimal places, but you just round off. Now let's see how we can use such to come up with the solutions to these questions. Part A. The first thing to do is to prime factorize to come up with that. So we shall let y be equal to 3 to the power x to come up with a quadratic. Then solve the quadratic by factorizing. I believe by now you know all these steps to get the two values of y. Then you remember that y is equal to this, but y should be greater. I think you remember that, and in the rules of indices can never be a negative, so this is not okay. Mean that we only have y equal to 5. So when y is equal to 5, it means that 3 to the power x is equal to 5. But here we cannot prime factorize 5. That is why we bring in the knowledge of logarithms. Then bring the power down to come up with this. Then you divide both sides by log 3, and use a calculator. And that will be the answer. Let's go to part B also. Part B, you are going to still do the same. Let y be equal to that. Substitute to get a quadratic equation. Then solve the quadratic equation to get the two values of y. I believe by now all these steps are familiar to you. So we have got the two values of y. Both are positive, meaning we shall deal with both of them. When y is 2, this is that. Introduce logarithms and make x the subject, use a calculator. What about when y is a half? Equate, introduce logarithms and make x the subject, then get the answer using a calculator. As simple as that. Then let's also do part C so that you grasp the concept. That is what we are given. So we can let y be equal to 2 to the power x, introduce y, get a quadratic, solve it, and get the two values of y. Then when y is 3, we have that. Bring in logarithms and then use a calculator. When y is 1, there you can use indices because a number at power 0 is 1. So x is 0. And that is it. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solutions to assignment 1. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Hello viewers, who are gathering taking you through the story of O-level math contest practice. And this video we are going to go through the solutions for week 2 of math contest assignment 1 for the year 2023. So the whole of this week the assignments will be on the basics of algebra. So question 1 says, if this symbol is defined by x, this symbol y is equal to x, the first one is squared minus the second term, what comes after this symbol? Then, and this symbol is defined by this expression whereby the first one is this, then plus the second one being squared. So should begin with, so in that case they have defined what this symbol means and what this symbol means. So usually we have been used to 4 operations, that is plus, minus, multiplication and division. Okay, but now they can bring in other symbols, but they have to define what they mean. So in this case, they have told us what this means and what this means. Meaning now they can ask questions involving those symbols. So X, this symbol Y in brackets, then this symbol Y. They want its value. So you should be keen and remember to use BODMAS. BODMAS means you begin with what is in the bracket. So we're going to come here and say that this one, we're given that, meaning that this is that. Okay. But they said after that, after getting this value, you put another symbol which is here. So we shall come and say that therefore this means what was here, we are going to replace it with this. That is why we are saying this. But now this one has not yet been replaced. So we have to go back and see what it means. It means what comes first is squared. So the whole of this is going to be squared. That's why you see it here squared. Okay. Then minus what comes after that. So what comes after this symbol is just y. So that's why you put y here. Now we have dealt with this symbol. Now we can proceed with the symbols which we are conversant with. Because I believe we are conversant with addition, multiplication, subtraction, and division. So now we are conversant with this addition and this minus, meaning we can proceed. So the first thing to do is to expand this. I think you remember in algebra, we learned how to expand this, and we said what you do, get this one and square it, then plus twice the product of these two. So 2 times x times y squared gives you 2xy squared. Then after that you say plus the square of this, which is y to the power 4. Then there is this minus y. Okay, after that you ask yourself, can I collect like terms? There's nothing, so it means that's what they wanted. Question 2 still, they give us now a star. So x star y is equal to this. If a and b are positive integers, say that a star b is equal to 9 and b star a is equal to 72, what is the value of a over b? And they said express your answer as a common fraction. So we shall come here and say that given this, it implies that from a star b, it means that here now a becomes x becomes a and b becomes y becomes b. So meaning that this side where there is x we shall put a and where there is y we shall put b. When you do that, you shall come up with this equation. Now you realize that 2a is common, so factorize it out to come up with equation 1. What about the second part of b star a? B star a still, it means that your x becomes b and y becomes a. So where there is x, we shall put b, and where there is y, we shall put a. To come up with this, then you realize that 2b is common, so pull it out to come up with equation 2. Now the value they want is for a over b. Here we have a, here we have b, meaning to solve them simultaneously, we shall say equation 1 divided by equation 2. So when you do that, you shall come up with this, and you realize that this is the same as this, and also 2 can cancel. So this side you remain with a over b, and this side you remain with 9 over 72, which can be reduced to 1 over 8. And that's what they wanted. Then question 3 says, simplify the following expressions. Now this one, there are 2 ways of doing it. Let me start with a shorter one by saying let x be this term and y be this term. Then when you replace, remember we don't use calculators. Then when you replace, this becomes x and this is minus 2xy, then plus y squared. Does this one look familiar? It should be. It came from the perfect square of x minus y, because if you say x minus y squared, you'll come up with this expression. I believe if you have gone through the video for algebraic expressions, which we learned in the previous solid D, you'll know that you are confident that this is the same as this. Then we shall replace our x and our y. So this minus this gives you 1. A number 1 to power n number gives you 1. And that's what they wanted. That is one way. But what if I don't want to do it that way? What do? I just let the smallest, look at these ones. I'll let this one to be equal to x. Then I'll substitute. So if this is x, it means that 2014 is x plus 1. 2x plus 1, x squared. Then I'll expand and collect like terms. So if I expand this, I'll come up with this bracket. Expand this, I'll come up with this. Then this is alone. Now here we collect like terms. This goes with, okay, if you look at this, and this gives you 2x squared. But there's minus 2x squared, so they both go. Then this and this goes away because of this minus. So I'll only remain with 1. Okay, this is how we can say it. Then you remain with only 1. So I think we realize that we get the same answer. So any of the two approaches is okay. Then question 4, without using a calculator, find the value of this. So these values are big and they don't want us to use a calculator. But there's just one little logic which you have seen in question 3. So you're going to let the smallest. There is this, there is this, there is this. So this is the smallest. That's what we let to be x. Then we come and substitute. Where there is this, we put there x. This we put x plus 1. This is x. This is x plus 2. Then we expand. This gives you that. And this gives you this. After that, we collect like terms. You realize that this and this cancels. This and this cancels. So denominator will remain with only 1. Meaning it will be x over 1, which is x, and we saw that x is this. So that is what they wanted. Then question 5 says, without using tables or a calculator, find the last 2 digits of this. So these values are also very big, but they don't want you to use a calculator. So what do? You need to know a logic that if I multiply the last 2 of each term digits, I'll be able to get the last 2 digits they want. So I'll come and say, let me first begin with these first 2 terms. I'll pick out the last 2 digits and I multiply them without using a calculator, meaning that here I've not shown how this comes about, but for your case you have to show us that to get it I have to get 8, 9, then 4 and 2, then you multiply. I think you know that procedure from primary to come up with this. Then you realize that the last 2 digits of this product is 3, 8. What if I want the last 2 digits of the whole of this? I'll say now the last 2 digits of this, which is 3, 8, times the last 2 digits of this, which is 31. And when I multiply the 2, I come up with this, meaning that the last 2 digits we required are 7, 8. So basically that was the solutions for assignment 1, and now I'll leave you with assignment 2. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be on solutions to assignment 2. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Hello viewers, Wagadaruna taking you through this tutorial for O-Level Math Contest Practice. And this video, I'm going to go through the solutions for week 2 and assignment 2 for the year 2023. So this assignment is on algebra and in particular indices. So question 1 says, what is a half of 2 to the power 2012? So half of it will be a half times this. Then remember that this is a half. In reciprocals, it becomes 2 to the power negative 1. I think you remember that, negative indices. Then this one now, it becomes same base. So we're going to add the powers to become 2 to the power negative 1 plus 2012, which gives you 2 to the power 2011. And that's what they want. Then question 2 says, if this is equal to this, what is the value of this? So the first thing to do is to prime factorize. 4 becomes 2 to the power 2, so 2 to the power 2 to the power x is the same as 2 to the power 2x. I think remember that law, that rule of indices, rule of power, where a to power, let me write here, a to power m, everything to power n is the same as a to power m times n. So that's what we have done here to get 2x. So applies this becomes 2 to the power 3y. But we are told that 2x is equal to 3y plus 5. So where there is 2x, I'll come and put there 3y plus 5 to come up with this. Then from there, I realize that this is the same base. So we are going to subtract the powers. So keep the base, subtract the powers. You realize that this and this will cancel and remain with only a power of 5. And that's what they wanted. Then question 3 says, simplify the following expression. So the first thing to do is to make everything under the same base. Reciprocal, I think remember reciprocal of this gives a negative, the sign on the power changes. For example, if you look at this, it was 1 over a and the power was negative 2. When I get the reciprocal, it becomes 8 over 1, which is the same as a, and the sign changes. See, it was negative, so it becomes positive. Same applies to this. The negative is maintained, for which it doesn't change. But this reciprocal, getting the reciprocal, changes the sign on the power. That is why you see here the power is now positive 3. Now we have succeeded in making them under the same base, everything. But this is minus. If it was multiplication or division, it would be easier. But now it is minus. What you are going to do, pull out the negative 1. Sorry, pull out negative 1, you will remain with positive here and positive here. Also this, pull out negative 1, you remain with positive here and positive here. Then you realize that this and this can cancel, so remain with only 1. And that's what they wanted. Question 4. Given that p plus q is equal to 0 and p is not equal to 0, determine the value of this. So let's start with this one. From this, it means that p is equal to negative q. Okay, but here we have a fraction of p over q. So what I'm going to do, what if I divide both sides by q? What will I get? I'll get p over q being equal to negative 1. Okay, so let me leave that aside and then I come to what was given here. So this one, the bases are different but the powers are the same, so I can put everything under the same power. Then I remember that p over q is negative 1, so the whole of this will be replaced by negative 1. Okay, then here negative 1 raised to an even power, it gives a positive 1. But if it is an odd power, the answer is negative 1. For example, let's try to see if I have negative 1 to power 3, it means the answer will be negative 1, because negative 1 times negative 1, that is already positive 1. Positive 1 times negative 1 is negative 1. What if it is negative 1 to the power 4? What will be the answer? The answer will be positive 1. So each time the power is even, the answer is positive 1. But when the power is odd, the answer is negative 1. So for this one, the power is even, that is why you see a positive 1 here. You maintain the 2 to come up with a 3, and that's what they wanted. Question 5. Suppose that this is equal to this. Find the value of that. So let's first simplify this given the index. From that, it means that this one can be split to become 3 to power 2x times 3 to power 1. Then this one becomes 4 times 3. Now this 3 and this 3 can cancel, remain with this equal to this. Now here, even if we prime factorize, we can't get a base of 3. So we're going to first leave it like that, then we come and deal with what they want. So since 81 is equal to 3 to power 4, it implies that 1 over 81 to power x is the same as 1 over 3 to power 4, everything to power x, whereby this is a power and this is also a power, so it can come up with this. Then to come up with from here, what I want is to come up with something similar to this, so that's why you put the 2 out, because 4x is the same as 2x times 2, which is first put the 2 outside, remain with 2x inside. Then from there, realize that this is this, so I can replace. Therefore, I'll replace this with 4 to come up with 1 over 4 to power 2. And 4 to power 2 is 16, so it is 1 over 16. And that's what they wanted. Question 6 says, evaluate this. So when you realize that this is to power 0, and also this is to power 0. In indices, I think you remember we said anything to power 0 is 1. So this will become 1 here. Then this becomes 2 to power 4. The whole of this also becomes 1 because it is raised to the power 0. 64 becomes 2 to power 6. 32 becomes 2 to power 5 when you prime factorize. Okay, then these are all powers, so I can multiply them. Also, these ones are all powers, I can multiply them. And this one I can get the reciprocal, so the sign changes. It was positive 4, now it is negative 4. So this is this, then this one here is here. Then this one, when I multiply these two, I'll come up with negative 3, which gives you 2 to power negative 3. Multiply this, you come up with negative 4, so it gives you 2 to power negative 4. Then negative indices, you realize that, okay, first of all, this and this can cancel. So I remain with 1 minus this, which is 1 minus reciprocal, which is 1 over 2 to power 3. This 2 to power 3 is 8. So 1 minus 1 over 8 gives you 7 over 8. Question 7 says, find the value of x if this dot means multiplication. So we're going to first change it to what we know, multiplication sign. Then we realize that this base, this power and this power is the same, so I can pull it out. And here the base will become that. I think that is the rule of indices. Hope you remember it. Then when I multiply this one, this root 3 times root 3 is 3, then times this 3 to give you 9, raised to the power x. Then in prime factorizing, this becomes 3 to the power 2, but there's also a power of x, so it becomes 3 to the power 2x. This one becomes fractional indices, it becomes 3 to the power a half. So this same base, so I can cancel to remain with 2x equal to a half. And in the end, x will be a quarter. Then question 8 says, what is the remainder when this is divided by 7? So here we need to first analyze the pattern. Let's begin with 3 to the power 2. Now we are starting with 3 to the power 2. Why? Why didn't we start with 3 to the power 1? Because 3 to the power 1 over 7, you realize that the divisor is bigger than this. So we can't do that. So it becomes already a proper fraction. Yet we needed an improper fraction. So that's why I began with 3 to the power 2. So 3 to the power 2 becomes 9. 9 divided by 7 in form of a mixed fraction, it is this. And you know what it means? It means 1 remainder 2. Let's increase again. 3 to the power 3 is 27. Divided by 7, you get 3 remainder 6. Increase again. 3 to the power 4 is 81. Divided by 7, 11 remainder 4. 3 to the power 5 is 243. Divided by 7, 34 remainder 5. 3 to the power 6 is 729. Divided by 7, 104 remainder 1. So here it means that multiples of 6, the remainder will always be 1. Therefore, this 2 and 280 is, when you divide this by 6, you get 336 and the remainder 2. So that means this is the same as 3 times 6 times 336 plus 2 if you use a calculator. So come and replace it with this. Then laws of indices, this can give you this and this plus 2 to give you 3 to the power 2. Now we already know the remainder for 3 to the power 2, when divided by 7, the remainder is 2. And the remainder for this multiple of 6 is 1. So I'll replace. Therefore, the remainder will be, here to be 1 and here to be 2 to give you 2 in the end. Then question 9, suppose this is equal to this. Find the value of x and y. So what I wanted you to realize first is the difference of two squares. So always be keen to analyze the difference of two squares in algebra. So that's what was given. Difference of two squares, it becomes this squared minus this squared. It is equal to this. Okay, so this is the same thing, only that here we multiply the powers to become 6 to the power 60, 6 to the power negative 60. So do you know what that means? It means that I can equate this to this, or this to this, because they are the same actually. So that means that 3 to the power x times h to the power y is equal to 6 to the power 60. And this 6 is the same as 2 times 3. And this h can be prime factorized to give you this. So that means that by comparison, this 2 with this 2, it means that 60 is equal to 3y. And also this 3 with this 3, it means 60 is equal to x. Therefore, x is equal to 30 and 60 is equal to 3y, implying that y is equal to 20. And that's what they wanted. Then question 10, given that this is equal to this, where b is greater than 1, find the value of b. So the first thing to do is to convert to base 10. So this 2, 4 base b to base 10 gives you this, but it is squared. So bring the power there. Then convert this to base 10 to give you this. Simplify. This gives you that, and this gives you this. Expand this, because now it is in base 10 to give you this. Collect like terms. If I take this 4 this side, 6 minus 4 is 2, that's why there is 2 here, to be squared. Then take this 16 this side, 4 minus 16 gives you negative 12b. Then take this 16 this side, 2 minus 16 is negative 14, so you remain with 0. Then divide throughout by 2 to come up with this simplified quadratic equation. Now here you can either use the quadratic formula or factorization to get the values of b. So let me use factorization. I have to look for two factors whose sum is negative 6 and product is negative 1 times negative 7. So product should be negative 7. So those factors are these ones. Therefore, come and split the middle term into this, which was got from here. Then factorize by grouping. For this one, if I pull out b, I remain with b here and negative 7 here. Here I remain with, if I pull out 1, b negative 7. So pull out b minus 7 here, you remain with b plus 1 equal to 0. So that means that either this is equal to 0 or this is equal to 0, implying that b is equal to 7 or b is equal to negative 1. Then you come and remember this condition, b must be greater than 1. Therefore, b can't be negative 1, implying that b is 7. And that's what they wanted. So now I'll leave you with assignment 4. So that brings us to the end of this video. Thank you for watching, and bear in mind that this video will be on solutions to assignment 3. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Hello viewers, Wagadaruna taking you through the story for O-level math contest practice. And this video we're going to go through the solutions to week 2 math contest assignment 3 for the year 2023. So this assignment is entirely under the topic of SADS. So question 1 says, without using a calculator, evaluate this. So the first thing to realize is that there is a difference of two squares. So difference of two squares will get a product of the difference and the sum. So this minus this is this, this minus that is that. Then you realize that this here we have 9 times 10, and this is 25 times 10. So you can have 9 times 25 times 100. These are all perfect squares, so 9 is 3 squared, 25 is 5 squared, 100 is 10 squared. The powers are all the same, meaning I can pull them out. Then this square root is the same as power half. So because of this square which is outside, it goes with this square root and remain with 5 times 3 times 10. 5 times 3 is 15, times 10 is 150. and that's what they wanted. Then question 2, evaluate the cube root of this quotient. So it is a little tricky, but there is a pattern which you will realize. And the first thing to do to identify that pattern, you have to factorize what is common. So if I factorize this for the numerator, here are, how do I factorize? So 1 has gone here, so I remain with 1. This with this, I remain with 1. This with this, I remain with 1. What about for the next term? So you go bracket by bracket, this alone, this alone, this alone, and this alone. So 2 divided by 1 is this 2, 4 divided by 2 is this 2, 8 divided by 4 is that 2. Then here, 3 divided by 1, 3, 6 divided by 2, 3, 12 divided by 4, 3. Then here, 4 divided by 1, 4, 8 divided by 2, 4, 16 divided by 4, 4. So I think you realize you have found out the pattern. Let's go to the denominator. The whole of this is here, so this is 1, 1, 1. For the next, 2 divided by 1 is 2, 6 divided by 3, 2, 18 divided by 9, 2. Then here, 3 divided by 1, 9 divided by 3, 27 divided by 9. Then here, 4 divided by 1, 12 divided by 3, 36 divided by 9. Okay, now all those are cubes. This bracket gives 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. Here the bracket gives 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. So you realize that the whole of this can cancel, and you remain with the cube root of 8 over 27. 8 is 2 cubed, 27 is 3 cubed. So these two can go with this to remain with 2 over 3. And that's what they wanted. Then question 3, evaluate x power 4 where x is this. The first thing to realize is that square root of 1 is 1. So this will be replaced with 1 to come up with 1 plus 1, which is 2. Which is here. Okay, then I'll square it. Square both sides. This square goes away, and here will come up with x squared. Then, but they want x power 4. It means that x power 4 is the square of x squared. So square this again. That is a perfect square, so to expand it, this squared plus twice the product of the inner terms, then plus the square of the next term. Correct like terms will come up with this, and that is what they wanted. Question 4, using a calculator, without using a calculator, evaluate this. So this was tricky, but we are supposed to let. So let this first part be A and this part be B. It means that now gx becomes 1 over A plus 1 over B. Get LCM, which is AB, you remain with B plus A. So the first thing to do is to get the product of AB, this denominator. So this times this gives you this, and you realize that's a difference of 2 squares. So difference of 2 squares gives that. This squared is that, this squared is this. Then when you subtract these two, you come up with a quarter. Square root of a quarter is a half. So we have now got the denominator as 0.5. What about the numerator? The numerator is tricky, but the only way to reduce on the sides is to first get the square. So b plus a squared, expand it to give you this. So this b squared, it means the square root goes away. Then 2ab, 2, and ab is known as a half. Then a squared, square root goes away. So next is to collect like terms. This cancels with this, so remain with this. Here it becomes 1 and remain with this. When I add all this, I'll come up with 4. But this 4 is for b plus a squared. But remember, our numerator is just b plus a. So we need to get a square root. So b plus a is 2. Now I have a numerator and I have a denominator. So I can get my gx as 4. And that's what they wanted. Question 5. Find the numbers m and n such that this is equal to this. So here, this is what is given. We are going to first square both sides. So when I square this, I'll come up with this squared plus twice the product of the inner terms, which is this. Then square this to give you this. What about here? When I square, this is 4, and here the square root goes away. Then here I've just rearranged this and this, then followed by this. And here, open brackets, this gives you 8, and this with this gives you that. Now but here there was a 4, and here we had a 2. So how could we bring in 2 here? It means we should remember that 4 is the same as 2 times 2. And when this one of the 2 goes inside, it becomes 4 because square root of 4 is 2. Then you'll come up with this. I think now it is similar because we have a 2 here, and a square root. Meaning I can now compare. M plus n is equal to 8, implying that m is 8 minus n. Then here mn is equal to 12. So when I substitute for equation 1 into equation 2, so these are 2 equations, I need to solve them simultaneously. I'll come up with that, open brackets, I'll get a quadratic. Then I solve. I have to get sum. Factors whose sum is -8 and product is 12. Those factors are these ones. So I'll come and split the middle term. So here you realize that there's a step I've skipped. Why have I skipped it? It is because the coefficient of this is 1. I think you remember it when we are dealing with factorizing quadratic expressions. When its coefficient is 1, I do not need to split the middle term. However, if I do so, I'll still come up with this. So how did this come about? After getting these ones, your work is to just say n minus that or n plus that to give you this. Then again n plus this to give you this. As simple as that. That means that the values of n are this or this. So after getting the values of n, I need to get the corresponding values of m. But I know that from equation 1, when I know n, I can get m. So I'll come and substitute. So when n is 6, m is 2. And when n is 2, m is 6. And that's what they wanted. So now I'll leave you with assignment 4 on logarithms. So that brings us to the end of this video. Thanks for watching, and Bear in mind the next video will be on solutions to assignment 4. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Hello viewers, Wagadaruna taking you through the story of O-level math contest practice. And this video I'm going to go through the solutions for week 2, assignment 4 for the year 2023. So this assignment is mainly on logarithms. So question 1 says, what is the value of this? So first thing to do, I think realize that here it is base 5. So you have to prime factorize this with a base of 5. So the biggest is 6 to 5, so that's what I shall start with. Divide by 5, you get 125. Divide by 5, you get 25. Divide by 5, you get 5. Divide by 5, you get 1. So that means 1, 2, 3, 4, 6 to 5 is equal to 5 to power 4. Then 125 is 5 to the power 3. 25 is 5 to the power 2. 5 to power 3, 5 to power 2. Then we shall use rules of indices. Same base, you add the powers. So add this and this to give you 5 to power 7. Then still rules of indices, same base, you subtract the powers. Then you can now use rule number 3 of logarithms, where this comes down to give you that. Then here I think realize that these are the same. So rule number 5 of logarithms makes it 1. So 5 times 1 is 5. And that's what they wanted. Then question 2, what is the value of this? So I want to start from the most inner bracket, which is this. So this most inner bracket, this is base 4. So I'm going to factorize this with a base with 4. Because I want to get a value of 4 to power what? To get this. So divide by 4, 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 divide by 4. So now we shall count 1, 2, 3, 4, 5, 6, 7, 8. So the whole of this is 4 to the power 8. Therefore, we shall come and write that this alone is log base 4 of 4 to the power 8. Then we shall know that this power can come down to give you this. Then you realize that these are the same, so it becomes 1. So 8 times 1 gives you 8. Okay, now you go to the next. Now that we have seen that the whole of this is 8, that means that now we have the whole of this will now be log base 2 of 8. And we also know that 8 is 2 to the power 3. Bring down the power to give you this. Look at this, they are the same, so the whole of this becomes 1. 3 times 1 is 3. So that means that the entire expression which was given, that is it. Then you shall replace from here up to here. It is 3. So that's why you see here 3. Then you'll be left with log base 3 of 3 to the power 2018, which is here. Then this Now here we realize that log base 3 of 3 is 1. Then any number to power 1, you get 1. And that's the answer they wanted. Then question 3, what is the value of this? So we're going to first remove out this square root and see how we can express it in terms of indices. Let's begin with the smallest one. This one alone is 2 to the power half. Okay, what about these two? 2 root 2 is the same as 2 to the power 1 times 2 to the power half. Same base, you add the powers to give you 2 to the power 3 over 2. Okay, now you have got this. What about the whole of this? It's the same as 2 to the power 1 times the whole of this, which is 2 to the power. Remember, this one inside is this, which was 2 to the power 3 over 2, but it is under a square root. That is why we again we put a power of a half. Then roots of indices, these are both powers, so it becomes multiply 3 over 2 times 1 over 2 to give you 3 over 4. Same base, we are going to add the powers to come up with 2 to the power 7 over 4. Now I've dealt with this, but there is this one more remaining. So let's work on it. That means that it will be this times this to power half. The whole of this is here, which is this. Then raise it to the power half. Multiply these two powers to give you 7 over 8. Then same base, add the powers to give you this, which is 15 over 8. So you have expressed the whole of this in terms of indices, which is 2 to the power 15 over 8. Now I can get the expression they want. This will be equal to a half plus log base 2 of 2 to the power 15 over 8, meaning this can come down. And then the whole of this is equal to 1. Then use a calculator, add the whole of this, you get 16 over 8, which is 2. Then question 4, what are the roots of the following equations? Now here the good thing, both of them are in base 2. Meaning that because this is addition, it will be multiplication. Then to eliminate the logarithm, it will say 2 to the power 1 is equal to this. 2 to the power 1 is 2, and this open brackets, you get that. Now that is a quadratic. We're going to put everything on one side to get a quadratic equation, which can be solved by either a quadratic formula or factorization. So factors whose sum is 1 and product is -2 are 2 and -1, meaning that the factors will be this, and therefore you can get the values of x. But this is negative. If you press or calculate, a log of a negative number gives a math error. Therefore, you shall come as that. Therefore, this can't be that, and therefore x is equal to 1. Question 5. Suppose that a and x are two positive real numbers for which this plus this is equal to 3. What is the value of this? So these ones are of different bases. We are going to first multiply the two, multiply both sides. We are doing so because here the value they want has a square, meaning by all means you have to bring in the square, and that is by multiplying both sides, by putting a square in both sides. Then expanding, I think remember the rules of algebra, to expand means square this, then plus twice the product of these two entries, then plus square this. So this one is here, and this is here, meaning that this one has to go the other side. If you remember in the notes, it will be easier to realize that the whole of this is equal to 1. Why? Because it is just an interchange. Here it was base x, which was the base, x was the base, and here a was the base. So this product gives you 1. We proved it some time back, but if you have forgotten, then you have to first remember this, then you can substitute. On substitution, you realize that it becomes 1 still. So this will go this side to come up with the expression they had given us. So that means that the given expression is equal to 7. And that's what they wanted. So I'll now leave you with assignment 5, still on logarithms. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on solutions to assignment 5. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when the next video has been uploaded. Hello viewers, Wagadaruna taking you through the story of O-level math contest practice. And this video, I'm going to go through the solutions for week 2 assignment 5 for the year 2023. So this assignment is still on logarithms. So question 1 says, find the sum and product of all the solutions to the equation this. The good thing, all of them are to the same base, but there's something funny. Do you see this? There is a 2 here. Therefore, before you combine the logarithm, you have to first take the 2 away. So when this 2 goes back here, it becomes x squared. Now here there is nothing, also here it is nothing. So we can use the rule now. Rule number 2 for subtraction becomes division. So it becomes this divided by this. Then to eliminate the logarithm, I will say 10 to the power 1 is equal to this. Then I can cross multiply and then put everything on one side, factorize, and get the 2 values of x. Now they want the sum and product. The sum, it will be 0 plus 20, which is 20. The product is 0 times 20, which is 0. And that's what they wanted. Then question 2, find the sum of all positive values of x for which this is equal to this. So that is what is given. Then we can simplify a little. To remove this power on x, it comes here to become 3. And also remove this power, it comes here to become 6. Then we shall let y be equal to log base 27 of x. That means that this becomes 3y with a power, and this becomes 6y. Open this bracket, becomes 9y squared. put everything on one side and factorize. Then you'll get the two values of y. But remember the question had x, so you have to remember that y is equal to this. So when y is 0, it implies that the whole of this is equal to 0. Then to eliminate the logarithm, this to power this is equal to x. So x is 27 to the power 0, which is 1. Then when y is 2 over 3, it implies that log 27 of base x, log base 27 of x is this. Then again do the same. This to power this is equal to this. Then you can come up with 9. So those are the two values of they wanted, but they said sum of all the values. So the sum will be 1 plus 9, which gives you 10. That was question 2. Question 3 says, let this be equal to this, where this a is not equal to b, and ab is greater than 0, a is not equal to 1, and b is not equal to 1. Find the value of ab, a times b. So we shall start with what is given. Then we change base, so I change this to base a, I'll come up with this, reciprocal. Then cross multiply, take this one this side, you come up with a square. Then put square root on both sides, you'll come up with plus or minus 1. So it means that there are two options. Either a to the power negative 1 is equal to b, which is this, or a to the power positive 1 is equal to b, which is this. But remember they told us this one gives this, and this one gives this, so negative power gives a reciprocal. But this, they told us that a is not equal to b, so this is eliminated. When it is eliminated, we shall remain with cross multiply, we shall remain with 1 equal to ab. And they wanted the value of ab, so we have got it, and that will be the answer. Then question 4, find all values of k such that the equation this has exactly one root. So this was beyond you, but yeah, it's better that I give it to you so that next, if it comes in the math contest, you can deal with it. So this is what was given. Then to bring this one this here to get a power. Why am I doing that? It is because I want to remove the logarithm, but I cannot cross this logarithm when there is a 2 here. Therefore, the first thing to do is to take the 2 back. So that here there is positive 1, then I can easily cancel the logarithms. And when I cancel, I'll come up with this equal to this. Then I'll open brackets, collect like terms, which is now a quadratic. Now this is where the trick was. When they say exactly one root, you have to remember that from the general equation of quadratic equation, when they say exactly one real root, it means something. What does it mean? It means that b squared minus 4ac is equal to 0. So these conditions, we didn't cover them under quadratics, but this is, you have to remember it. When they say one real root, it means equal to 0. And the a, b, c are good from here, because this is a general equation. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is 2 minus k. And c is the coefficient is the one without x, and it is 1. Then I'll come and substitute in this condition for exactly one real root. B, put it here and square it, minus 4 times a times c. Then simplify, take this one this side, then put square root on both sides, plus or minus 2. So there are two values, either this can be equal to positive 2 or negative 2. When you use positive 2, we shall come up with k as 0. When you use negative 2, we shall come up with k as 4. And those are the two values of k. Then question 5, if m and n are non-negative real numbers such that this is greater than 0 and this is equal to this, find the ratio of m to n. This one was also tricky in its own way. So from here, I can take this side to give you this. Then by the side ratio of m to n, meaning it is n, m will be the numerator, n will be the denominator. So divide by n, both sides by n, you'll come up with m over n is greater than 2. Okay, let's just leave that on the side and we go to this, which is here. So first, I want to remove the logarithm, but to remove them, you see this, there is a 2 here, so it can't go away. Also here there is a plus, so it can't go away. Therefore, what do I do? The first thing to do is to take back this power, and also here to combine these two into one logarithm. So in short, for you to cancel these logarithms, there should be only one logarithm on each side. And 2, the coefficient is only positive 1. Now, because all the conditions are fulfilled here, there's positive 1, and 2, there's only one logarithm this side and one logarithm this side, and there's no other term, we can cancel this logarithm and we remain with this alone equal to this alone. Then I can expand and collect like terms. Take this one this side to give you negative 5mn. Then because I wanted the ratio, I'm going to divide throughout by mn, each term by mn. When I do that, here 1m will cancel, so I remain with m over n. Here, the whole of mn will cancel, so I remain with negative 5. Here, 1n will cancel, so I remain with n over m. Here it is 0, so I remain with 0. So let m over n be x, meaning that this one will become x. But this is the reciprocal, therefore I also replace with the reciprocal, which is 1 over x. Now this 4 comes from here. I think you see here there is a 4 times n over m. Then I can multiply throughout by x to get a quadratic and solve it to get the two values of x. So factors whose sum is negative 5 and product is positive 4 are negative 1, negative 4. Therefore, the factors are those and the values of x are those. So meaning when I replace, remember x was m over n, so it means that m over n is 1 for x equal to 1, and also m over n is 4 for x equal to 4. But you remember we are given that here, do you see this? That m over n must be greater than 2, yet here I have one which is smaller than 2. That means this is disqualified and I'll only take this. Therefore, the ratio is 4 to 1. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and bear in mind the next videos will be for week 3 assignments. So if you have not yet subscribed, please click on the subscribe button so that you can receive updates when the next video has been uploaded.